we will study about clipper circuits and clamper circuits. Okay. So in previous class we have seen about rectifiers and filter circuits. Okay. So in this class we will study about clippers and clampers. Okay. So clippers, first of all we have to define what are clipper circuits. Okay. So clipper circuits are those circuits which will clip. Suppose this is the input waveform. This is say Vi. Okay, Vi. Now what is the use of clipper circuit? Clipper circuit, it will clip some portion of the input, either this portion or complete portion. Okay, so clippers are the circuits that clip some portions of the input waveform, without disturbing the remaining part of the waveform. Okay, so clipper circuits are the circuits which are used for clipping of some inputs. So this is say any input waveform. Okay, so clippers, either it may clip this part complete or it may clip this part. Okay, so this is the main function of clipper circuit. Okay, so we will study now types of clipper circuit. Okay, first is we will study about series clipper. Okay, so in series clipper, what is the circuit? We will see the circuit. This is diode and this is RL, and voltage is appearing across the load. Okay, so here Vi is the input. Okay, so we can express Vi, it is equal to say Vm sin omega t. Okay, so the peak amplitude of Vi, it is Vm. Okay, now we can draw the input of waveform. Suppose this is Vi, okay, and this is omega t, 0, pi, 2 pi. Okay, now this is positive part and this is negative part of the input waveform. Okay, now in the output, what we will get during positive half cycle, that is from 0 to pi, or if this is time period, so it is 0, t by 2, then t. Okay, so from 0 to pi, this is for positive half cycle. Okay, and its peak amplitude, it is plus Vm, and here it is minus Vm. Okay, this is during positive half cycle. So positive half cycle, for this it is Vm. Okay, so during positive half cycle, this diode it will start conducting, and if we are considering this diode as ideal diode, then it will be shorted. Okay, so we can represent this diode by a short. Okay, so complete V output it is equal to V in. So here we are getting V in. This is 0, pi. Okay. Then during negative half cycle, we can see during negative half cycle this polarity it will change. Here it is minus and here it will be plus. This is minus and this is plus. So and this is P side and this is N side. Okay, so it will be in reverse bias condition. So diode in reverse bias condition, it can be represented as a open switch. So it can be represented as open switch. Okay, here it is open, so current I will be equal to 0. If I is equal to 0, so voltage drop across this RL it will be equal to 0. Okay, so here this is 0 and this interval is equal to this interval, and here this is Vm, this is V out versus omega t. So this is the input waveform and this is the output waveform. Okay, so what we have seen? We have seen that by using this circuit, this negative part is clipped. Complete negative part it is clipped. Okay, this part is clipped. Okay, this part is clipped. So this is one form of a clipper circuit. So this is the simplest clipper circuit, simplest form of clipper circuit. Okay. Now, if we will reverse the direction of diode, then what will happen? We will see the same circuit, but if the direction of diode is now changed, this is RL, okay, this is diode D, and this is say VI. VI it is equal to Vm sin omega t. Okay, and now the direction of this diode it is changed. Okay, now this is P side and this is N side. Okay, now we will see the input output waveform. See, this is Vm and this is Vi, 0, pi, 2 pi, this is 3 pi, this is omega t. Then for this type of input waveform, what will be the output across RL? This is positive half cycle of the input, this is negative half cycle of the input. Okay, now during positive half cycle means from 0 to pi. Okay, from 0 to pi, this is for positive, means here it is plus, here it is minus. This is during positive half cycle. During positive half cycle, this is plus and this is minus, and peak amplitude it is Vm. Vi it is equal to Vm sin omega t, and peak amplitude it is written as Vm. Okay. Now this is positive Okay, this is positive potential, and it is here it is N and here it is P. Okay, so this diode, it is in reverse bias. So in reverse bias, an ideal diode can be replaced with open switch. This is open, so this can be replaced with open. Okay, so what will happen? In that case, I is equal to 0. So if I is equal to 0, what will happen? V output, it is equal to 0. So during this interval, it is equal to 0. So this is the V output versus omega t graph. Okay. Now we will see from pi to 2 pi. From pi to 2 pi, this is for negative half cycle. Okay. So for negative half cycle, we will see. Okay. This is for negative half cycle. During negative half cycle, okay, this is negative and this will be positive, and here again it is Vm is the peak amplitude. This is Vm, peak amplitude of the negative part. Okay, so during negative half cycle, here it is minus, here it is negative potential, here it is positive potential. So negative potential, it is connected to N and this is P. Okay, so it is in forward bias condition. This is in forward bias condition. So in forward bias condition, this diode can be replaced and we can put one short like this, because for ideal case RF, it is equal to 0. That is forward resistance of the diode, it is equal to 0 for an ideal diode. Okay, so the circuit will look like this. So in this case, what will be the voltage across this? So the direction of current, it will now from this to this. Okay, so here it will be plus and here it is minus. So V output, it is equal to peak value, it is equal to minus Vi. So peak value, it is equal to minus Vm, or V output, it will be equal to minus Vi. Okay, and its peak value is minus Vm. So it will be like this, the same. This is minus Vm. Okay, peak value is minus Vm, and it is complete this signal, this from pi to 2 pi, this is pi and this is 2 pi, and for this from 2 pi to 3 pi, it will be in reverse bias condition and I will be equal to 0. So in reverse bias condition, I will be equal to 0. Then in that case, V output, it is equal to 0. So like this. So what we are saying, that positive part is clipped. This part is clipped. Okay. So this is the function of clipper, that some portions of the input waveform is clipped in the output without disturbing the remaining waveform. Okay, so this is the function of clipper. Then we will study about parallel clipper. Okay, Then we will study about parallel creeper. See, first is like this. This is V out and this is V in, Vi, okay. So Vi it is equal to Vm sine omega t, okay, and this is R and this is diode D. So this is one type of parallel creeper, okay. So in this circuit, suppose how we can show the input output waveform. Suppose this is say Vm and this is minus Vm, plus Vm, minus Vm, and this is Vi versus omega t. So omega t means 0, pi, and this is 2 pi, okay. Then what will be the output for this type of waveform? Here it is Vi it is equal to Vm sine omega t, okay. Okay, so from 0 to pi, this is positive half cycle. From pi to 2 pi, negative half cycle, and peak is plus Vm, peak is here it is minus Vm, okay. Now during positive half of the input, okay, during positive half of the input, what will happen? The polarity of this across this, it will be plus and minus. This is during positive half of input. So during positive half of the input, this we can see this diode, it is in forward bias condition, okay. This is positive and this is negative, and this is P terminal and this is N terminal, okay. So this is in this diode, it is in forward bias condition because positive terminal is connected to P side and negative terminal is negative potential or negative terminal is connected to N side. So this is in forward bias condition. So this diode can be replaced. So this diode can be replaced with a short if the diode is in ideal condition. If we are considering diode as ideal, then we can replace the diode with short, okay. So if the diode is replaced with short, okay, so what will happen? This is say Vm, okay. So we have to take V output across this point, these 2 points A and B, V output. So VA and VB, VA and VB both are at the same potential. So VA minus VB, it is equal to 0 because of short. Because of short, V naught it is equal to 0. Output across AB it is equal to 0 because this is short. Okay, so we can draw like this. From 0 to pi, it is equal to V output, it is equal to 0. This is the graph between V output versus omega t. Then we will see during negative half cycle, okay. So in negative half cycle, the polarity of the input, it changes. Here it is negative terminal and here it is positive terminal. Okay, so negative terminal is connected to P side and positive terminal is connected to N side of the diode. Okay, so due to this diode, it is in reverse bias condition. In reverse bias condition, we can replace this diode with open. Okay, we can replace this diode because we are considering this diode as idle diode. So in idle diode, in reverse bias condition, it can be replaced with open. So V output, what will be V output? V output, it will be just like this, same. Okay, so it is like this. Here it is minus Vm. Okay, so what we have observed? We have observed is that this is pi and here it is 2 pi. What we have observed? This is the input waveform and this is the output waveform. Positive half cycle, positive part is clipped, this part. Positive part is clipped. Okay, in the output we are seeing that positive part is clipped, only negative part is coming. This is same. Okay, so a clipper circuits, it clips some portion of the input waveform. Okay, then we have seen this type of parallel clipper. Then we will see if the direction of diode it is changed. Now, if the direction of diode is changed like this, then what will happen? Okay, the same circuit. Okay, see, this is Vi, it is equal to Vm sine omega t. Okay, and this is N side and this is P side of the diode, and AB, these are the 2 points across which we are measuring V out. Okay, so we will see this is the input waveform Vi, this is Vm and this is minus Vm. 0 here pi and this is 2 pi. This is omega t versus Vi. Okay, then for this type of waveform we will see the output waveform V out. See, this is positive half cycle and this is negative half cycle. Okay, so for positive half cycle, the polarity of the input it will be plus here and it is minus terminal here. Okay, this is plus and this is minus. Okay, now during positive half cycle, this positive terminal is connected to N side of the diode, and negative terminal is connected to P side of the diode. What does this mean? This means that this diode it is in reverse bias condition. So in reverse bias condition, we will replace this diode with open. Okay, this diode is replaced with open. So what will be V out? V out, it will be the same, plus minus the same. Okay, so here we will get the same signal. Okay, and this is Vm. Now during negative half cycle, here it is minus and here it is plus. Okay, here it is minus and here it is plus. Okay, this positive terminal it is connected to P side and negative negative potential or negative terminal, it is connected to N side. Okay, so under this condition, this diode it is in forward bias. Okay, so in forward bias condition, we can replace this diode with short. Okay, so this is replaced with short. So V output it is equal to 0. Why V output is 0? Because we are measuring voltage across point A and B. Point A and B, and it is shorted. Shorted means potential at A, that is V at A and V at B, both are same. Potential at A and potential at B both are same. So if these two voltages VA and VB both are same, then VA minus VB it is equal to 0. That is why V output is equal to 0. So we are saying that this is 0 from 0 to pi, and this is 2 pi. So from 0 to pi it is the same waveform. Input and output waveform both are same, but from pi to 2 pi this negative part is clipped. So this part is clipped. So we have seen series clippers and parallel clippers. Okay. Suppose the input waveform is like this, Vi versus omega t. Okay, and this is Vm, and here it is minus Vm. So suppose we can clip this part also, this part, only this part. Okay, so how we can achieve only this part can be clipped? By adding some external voltage, some external DC voltage, some external DC bias we have to apply in the clipper. Then we can either clip this part or this part. Okay, like this. Okay, so for this we have to add some external DC bias. Okay, now we will see this is an example of clipper circuit in which an external DC bias voltage is applied. This voltage V, this voltage is V, and this voltage V is less than Vm. Vi, suppose Vi it is equal to Vm sin omega t. Okay, and this Vm it is more than this V. Okay, so here it is Vm and here it is V. Okay, now during positive half means from 0, pi and 2 pi, this is omega t. During positive half from 0 to pi, okay, this diode it will be in forward bias condition. So this is in forward bias condition from 0 to pi. Okay, so it will output it will be like this, from 0 to maximum it will be V, because here V output it will be equal to V, this is maximum. Okay, so it will be like this. Then during negative half cycle, this is negative half cycle and this is positive half cycle. So during negative half cycle, what it will be? V output will be, during negative half cycle it will be this diode, it will be replaced with open. So this will be open. So I will be equal to 0. If I is equal to 0, then V output it is equal to what? It is equal to Vi. It is equal to this complete Vi. Okay. So this is negative half cycle. For negative half cycle, this diode it is in reverse bias condition. So it is completely off. So we can say that this I it will be equal to 0, but here V0 it is equal to Vi. So the signal will be like this. Okay, so we are seeing the output. In the output, only this part is clipped. Means the signal, the input signal above this voltage, this voltage is what? This external voltage, external DC bias voltage. Okay, so this part is only clipped, and all the other shapes of the waveform, it remains the same. Only this part is clipped here. So this is because of the addition of some external DC bias voltage in this circuit, in this clipper circuit. Okay, so we can clip any part like this. We can clip also. So in this way we can clip some part of the input waveform. So now we will study about clamper circuit. Okay, so what is the function of clamper circuit? The clamper circuit, suppose this is the input waveform, this is any input waveform. So what any clamper circuit will work? Clamper circuit. So what is the function of clamper circuit? Clamper circuit, it shifts the DC level. It shifts the DC level of the input waveform. It shifts the DC level of the input waveform to a different DC level without any distortion in the input waveform. Okay, so it shifts the DC level of the input waveform to a different DC level without distorting the input waveform. So this is the function of a clamper circuit. It will shift the DC level of this input waveform to a different DC level without distorting this input waveform. Okay, so a clamper circuit, it consists of a capacitor, diode and resistor. Okay, so this is the circuit diagram of a clamper circuit. Okay, now this is capacitor C, this is diode D, and this is resistor R. So voltage is measured across R at point A and B. So we are measuring voltage across point A and B. Okay, so this is the circuit of a clamper circuit. Suppose this is the input waveform Vi that is applied to a clamper circuit. Then what will be the output of this clamper circuit? We will see. Say this is V out. So from 0 to T by 2, that is, this is T by 2, this is T. So time period T, from 0 to T by 2, here suppose this is plus V and this is minus V. Okay, from 0 to T by 2, that is during positive half cycle, and this is negative half cycle. So for positive half cycle, the direction of the polarity of input, it will be like this: positive terminal and negative terminal, negative potential. Okay, plus minus. Okay, so because of this, for positive half cycle, this diode, it will be in forward bias condition. It will be in forward bias condition, and if we are considering diode as adding diode, then it will be replaced with short. Okay. Now V output it is equal to 0. V output it is equal to 0. Why? Because this is short resistor, it is short, so VA and VB both are at the same potential. Okay, now VA minus VB, it is equal to 0. So V output, it is equal to 0. This is for positive half cycle. Okay, so from 0 to T by 2, it is like this. V output, it is equal to 0. 0 T by 2, and this is time period T. Okay, now during positive half cycle, this capacitor starts charging, and it starts charging, and voltage, maximum voltage it can store is this V, plus V, because its peak amplitude is plus V. This is the Vi, and peak amplitude of the input is V. Okay, so it will charge up to plus V. Okay, now its peak amplitude, it is V. If Vi, for this type of input Vi, its peak amplitude is plus V, and here peak amplitude is minus V. So it is plus V and it is plus V during positive half cycle. Okay, now during negative half cycle, this diode, it will be in reverse bias condition. So it can be replaced with open. This is open, so it can be replaced with open. Okay, now during positive half cycle, it was charged up to V, and this is also V. Okay, so plus V and plus V. Okay, now this is for negative half cycle, the polarity will like this, minus plus. Okay, so V output, it is equal to minus V plus minus V. It is equal to minus 2V. V output during negative half cycle, it will be minus 2V. So we can draw this waveform like this. Here it is minus 2V. Okay, so this is the same waveform what we are observing. This waveform, the same waveform, waveform is like this. Okay, this and this, 0 T by 2 T. Okay, and here we are seeing this, the same waveform, but here the peak amplitude in negative part, it is minus 2V. Okay, so what is observed? Only the DC level of the input, it has changed. So the function of circuit to change the DC level of the input waveform to a different DC level without changing this waveform. So it is changed to different DC level without changing this waveform. This is the function of clamper circuit. So we have just seen how the DC level of the output waveform has changed. Okay, so this is the main function of clamper circuit. So in this class we have seen about clipper circuits and clamper circuits. Clipper circuits are those circuits which clips some portion of the input waveform. Okay, and clamper circuits are those circuits which will shift the DC level of the input signal to a different DC level without distorting the input waveform. This is the main difference between clipper circuit and clamper circuit. And we have also seen different types of clipper circuits